Hello and welcome everyone. Well, this is where I would normally look around in the room and say, hi, it's good to see you. Where did you grab those cool t-shirts? But well, not today. Uh, the talk is called A Year with JDK 11 in Production. Technically, it's slightly over a year. The story is about how Revolut upgraded to JDK 11, now has been running JDK 11 for more than a year. In prod, what were some of the issues? What were some of the unexpected library changes that we had to do, some of the impacts and general things like that. My name is, as Kuba said, Andrzej Grzesik. I work at Revolut. I have a Twitter, an email, a blog. If you want to ask me anything about using Java or the software of Revolut, you have the Discord. Kuba will be amazing at relaying those questions to me. And if you want to talk about working at Revolut in general, hang out with me after the talk. I'll be happy to try to answer some of your questions maybe after. But during the slides, let's do questions about Java in the context of Revolut. Anything else after. A few facts about me. I'm proud to be a Java champion, old enough to have gone to Java 1 and to be a Java 1 rockstar. I run QCon, which sadly so far hasn't taken place. It was supposed to, but well, we all know the drill. I'm part of Polish Java user group, Software Craftsmanship Kraków, when I was still living in Kraków. Geographically, originally from Kraków, live in London. And a technical disclaimer, my opinions are my own. I'm not representing any organizations, especially those which I might happen to work at. If you have questions about the talk, as I say, just ask. I don't see the Discord channel, but Kuba will do an amazing job. It's probably the best way to make it slightly more interactive and to tailor it exactly to you because yeah, why not? We covered this. And joke slides are for when I should drink. So you get to read, hopefully smile, and I drink. So somebody some time ago, specifically 25th February, asked on Twitter, as many people did such surveys, which version of Java people are using in production. And now we can pretend we are in a room and I can see some people are raising hands for Java 8. I can see some people have raised their hands for Java pre-8. Some people maybe have raised their hands for 9 or 10. Don't worry, I'm not the NSA. If you're raising anything, I can see that. And Java 11, well, some people in the room here, I would actually wave as well. Java above 11, some brave souls. Obviously, those community-based surveys have a bias about them because what people think versus what enterprises use are sometimes two different worlds. Also, people talk about the JDKs they interact with on their daily basis. However, enterprises, especially those running thousands of VMs, maybe millions, they will have slightly different preference. So there was an interesting entry on New Relic's blog some time ago, I think sometime in March, about which versions of the JDK people are using within, from what New Relic can tell by people using their agent, which versions their agent reports. If you look at especially Java 8, and that's been broken down into current, lagging, and vulnerable, this easily is above 80%. 11 is at 11.11. This is, I would call it a funny coincidence, but clearly version 8 is what majority of people at the time of that blog post were using. Some people are 7, some people are pre-7, some people are running non-LTS releases. If you want to talk about Java release cycle, we will not cover that in detail today. That's something that I either hope you already know, or if you don't, we can do a short description of that after the talk. Another interesting thing to look at the data made available by New Relic is the JDK vendors usually, or when I started with Java, well, you went to Oracle's website, you downloaded the official JDK, and then that's how you went. Then you got some IBM related products, especially because of work related products, and they all came with their own JDKs. Same goes for WebLogic, same went for different things. Then I used to default to everything Oracle, but then something changed, as you probably remember from many talks that have been on the subject. And different vendors of the JDKs are a thing. Particularly interesting to me is the rise of Adopt Open JDK, partly because that's an organization that makes IBM Java available and you can get support for it. And partly because that's something in which London Java community, so the London JAG is hugely invested in terms of people who are part of that org. So you could say it's close to home. And then Amazon became a JDK vendor. Amazon, for those of they have their own JDK. It's called Coreto. It has a website, of course. It lists which patches they backport and frontport. Pivotal, I had no idea they do a JDK. Azul, yes, and SAP and Sun still. That probably says something about how old that particular JDK is. And Debian, I did not know Debian has its own JDK. But well, we're going to talk about Java Upgrade. And Java Upgrade is in a context. Revolut is a financial super app. Company was launched in July 2015. It's got millions of users, thousands of employees, multiple offices around the world. And I'm not going to do marketing about the company. Why I mention about the thing and what the numbers are is because those numbers have been reached in 5 years, which means this is a company that is in a very pleasant situation of growing like crazy. So if you were reading about the expansion and scalability challenges like from things like eBay, Amazon, well, we are having similar challenges, or maybe not challenges, technical questions to solve. So you need to combine distributed system knowledge and how to build software effectively, efficiently, how not to over-engineer, how to roll out, and where to make technical debt when it's reasonable. And because it deals with finance, we cannot really break things. So we cannot we cannot follow the early Facebook model of move fast and break things. No, we can't break things because people lose money, would get lost, and that's a no. Also, we get regulators to interact with, and they would spank us. Also, in this organization, we don't believe having 1,500 different microservices is the right approach. So we have much less. Some services, but less. Applications in the context of this specific organization usually follow this model. So there is CoreOS, and there will be a caveat about CoreOS in a second. Which means a typical application will run Java. Java application will run a framework called Java Spark, interact with usually Postgres via Juke, be contained within Docker. There will be some other things on the VM, but it's one application per VM. Always for us, which means we don't have large instances that run multiple Java apps. No, we prefer to have a bit more isolation. And then I mentioned FluentD, but there are supporting daemons running on the machine doing that various things. And CoreOS, I promised a caveat. CoreOS is, it's now reached its end of life. Hence this nice dinosaur picture, well, the skeleton of a dinosaur from Wikipedia, which means if you're using CoreOS, if you care about updates and upgrades, you will have to look into a migration path. Now, why did we upgrade? Why did Revolut decide to upgrade more than a year ago to recent JDK? Isn't it that many financial and many companies in general are happy with JDK 8 and they can get other stuff done? Well, there is a couple of reasons. First, there is a company philosophy of getting things done, and specifically, JDK 11 is something that many people were eager about and excited about, and that's a change that we would have to do anyway. I already touched on the move fast and keep things working, but we would have to upgrade anyway because JDK 8, as it was described some time ago, it was supposed not to be around in general availability for so long. And we care about software patches, obviously. We care about security fixes, and we want those new security fixes. We want those productivity enhancements, container friendliness. We want that. But also, there is a huge factor of people are excited about Java 11. And if that's a small way in which you can make all the developers that you use Java or JVM based languages happier, why not do it? And also, because we are running applications that do RESTful services, and RESTful services means this guy. I hope everybody recognizes JSON. And as I promised, you're supposed to smile, I'll drink. Up until Java 8 inclusive, string was internally contained char array. Char array means 2 bytes per character, which means, yes, you can have a very large string, but it will take more memory, twice what's necessary if you are limiting yourself to the ASCII subset. Of course, somebody can say you can do string dot duplication with G1 in JDK 8. And yes, that's correct. That will deduplicate underlying arrays, but this will not deduplicate string objects. And also, if you're running G1, then that means that full GC in JDK 8 is going to be single-threaded, which sometimes might not be exactly what you want. Also, JDK 8 G1 is not the same G1 that works currently, but specifically from the context of REST services and well, anything that does REST manipulation or text string manipulation, Java 9 brought this very nice change in the language, as in within the standard library, strings are now byte arrays, byte array based, which means one character will fit within 1 byte, as long as you're limiting yourself to a small subset of strings, because most of them are ASCII anyway. That's very frequently the case, which means you get this win for free. You just switch JDK versions and you move forward. Of course, if you really do care about memory and counting bytes for strings, you will end up with a string cache anyway. But for us, that meant, well, JSON became slightly happier. And now, well, upgrades. Obviously, upgrading Java, critical component for many applications, requires some ops interactions. From our point of view, it's not that we do have some ops people in the company, but it's on the handful side, not on the crowd side, which means it's developers who take care of many infrastructure tasks. We do automate things a lot. Ops people are there to work on specialized things. So it's usually normal engineers would look at YAML files and get to curse at that, while ops people would look at specific network peering settings. That's the distinction that we follow. But basically, because we automate heavily, which means we use infrastructure as code heavily, it was reasonably simple to use inheritance and templating to just roll out that change, because it's means changing a few properties in a limited number of places for the base JDK image that certain applications follow, and then changing the image that any application uses as its foundation to JDK 11. Specifically, what did we do? We upgraded from 8 U12 212 to 11. 11.11, so the first release of 11, and we did it to all of our applications. Somebody might ask a question here. Why did you not, for example, do 9? Why did you not do 10? The answer is 9 and 10 are no longer maintained, and they are short-lived. So doing that just for the 6 months, not really. At least 11 gives you LTS. Also, most stable, most popular libraries are converging on JDK 11 for the long-term support because it's a long-term support release. And why not 12? Well, because it wasn't available. We also switched from Oracle JDK. That's an important change we have adopted. Why did we decide to abandon Oracle JDK? Because if we're using Docker and we prepare an image, there is, if my understanding of Oracle legal language is correct, and I am not a lawyer, that if we cannot really build or redistribute Oracle JDK, which means it's not really following a license to grab Oracle JDK from the website, put it into a Docker container, and do magic things with that. Also, running Oracle JDK in production for version 11, for example, requires a license, and we don't have that license. We don't want to get a license, and we are quite happy with adopt. Now, I promised I'm not going to explain this in detail, but there's always a small subset of people that is super surprised that Java has a release cadence. So if you're seeing those slides for the first time, or you are very surprised about what do they actually mean, talk to me after the talk. I'm happy to explain it to you, but we'll just go through them very quickly. Java gets a new release every 6 months. It's what used to be a major release. Now it's just a release, and we are at 14 now. 3 builds for each major version, so you get 11, 11.01, 11.02, and that's it. Well, for 11 specifically, you get more because it's an LTS, but for 12 or for 10, you get 2 releases normally, and that's it. Why is it an LTS? An LTS because it gets fixes for a longer period. That's what it looks like graphically. Specific LTS releases, like 11 or like 17, get fixes for a longer period of time. And that's it. Questions about that? After the talk. Now, Java 11. If you want to do Java 11, you have 2 choices. You can compile on 11 and run on 11, or you can compile on 8 and run on 11. I've done the right version before, and it worked reasonably well. And it's also a good choice sometimes. It might be dictated to you by the libraries or the tooling that you are using within your infrastructure. But what we did at Revolut is 11 everywhere. Runtime and toolchain, everything runs 11. Everything defaults to 11. There is no magic about it. It's you download JDK 11. I remember coming to one of the companies I used to work with. I came in, I installed current Java, which was Java 5, and then I couldn't compile. And then I asked, "Hey guys, I can't compile." And then everybody was laughing, "Ha ha ha! You silly person! You took Java 5, we're Java 4." But it's yeah. You probably know similar situations from your own lives. The nice thing, at least for me right now, is Java 11 is a very reasonable version to run in 2020. We run it everywhere. We don't have to fiddle with Gradle using a different version and some, I don't know, generators using different version. Why would you want to do something else? So why would you want to run Java 11 but not use the toolchain? Well, there might be a couple of libraries that give you this very not exciting opportunities. Specifically, if you're using older Cassandra, older Grails, older Hadoop, older Kafka, older Spring Boot, older Thrift, you might need to be on an older version of the JDK. I'm saying might because this list is based on advertised features. I have not verified those tools. Actually, I only happen to work with Grails because QCon's website is in Grails, and that's holding us back. But that's a side story. Good for after the talk. So build tools. If you want to do the upgrade, or if you're in the process of upgrading, what can you do? What build tools should you use to help you with that? Well, first of all, JDK comes with JDEPs that can show you module dependencies, because of course JDK 11 as JDK 9 and 10 includes modules, and the core JDK is modularized. So you can do JDEPs minus da 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 da, or you can use a Gradle plugin or a Maven plugin. Is there an AND plugin? I have no idea. I haven't touched AND in quite a while. There is also JDepper scan, which scans for usage of deprecated APIs. Why? Because Java now removes some APIs that have been marked for deletion in their deprecated annotation. Gradle and Maven, obvious. Also, if you want to do Java 11 on Maven, you just use Maven compiler plugin in version 3.8.0 or anything past that. You ask it to source and target, but Maven is what everybody knows. And then with Maven, I should mention two other useful things. So if you're using Maven, you'll probably have some plugins in your builds. You can use versions plugin to display plugin updates. So it can tell you what plugins can be updated to what versions. As you can see, this list can be quite long and comprehensive. Maven not only is an internet download tool, it's also a very good text generator. And also Maven has a versions, the versions plugin can display dependency updates. So it can tell you if some libraries that you have within your build can be updated. It is useful if you want to go through the journey. Gradle. If you're using Gradle, the first thing that you might want to do is upgrading Gradle to version 5 or 6 if you want to run JDK 11. If you're before, first upgrade to V5, then upgrade to V6. Don't do V5 to V6 immediately. This would be a roller coaster ride. And now something about libraries. Mockito, quite popular, obviously, especially in Poland, especially in Krakow where it was born. Formally supports JDK 11 since version 220.1. Releases that mention JDK 11 supports are at least some, based on GitHub release logs. 291, the actual numbers don't really matter. There were multiple. What I'm mentioning here between the lines, it was supposed to be simple. Everybody thought it's just going to be a release that supports JDK 11, and then people discovered tiny bugs. It used to be the case before, early on, but now JDK 11 has been a while with us, which means now it's much safer to update. Just take current version of whatever is there, and you're probably good to go. If you were on the journey as early as we were, you probably have discovered some library incompatibilities similar to that. I said we use Juke. Juke supported JDK 11 since 3.12.0. We're now on 3.13. What you don't know is that we didn't update Juke because of JDK 11. We actually kept on 3.11 for quite a while. Why? Because it worked. Also, why not upgrade if I mentioned we're such a forward-thinking organization? Because Juke is not where it makes a difference. It's important to keep it updated, so we have updated it, but it's not at the core. It's in the supporting domain. So because of that, it could have waited a bit. And we eventually updated it when it was safe to do so. Flyway. If you're migrating databases or if you're writing database migrations, Flyway is an awesome framework. If you've never used Flyway and the only thing you remember from the JDK presentation is that there is this tool called Flyway that you were told to try, yes, please do it. It's awesome. I wholeheartedly recommend it, especially if you combine it with test containers. It's really nice for isolated and repeatable tests. What it does is manages your database migrations for an application. So if you have a lot of migrations, it will execute them in order. Flyway supports JDK 11 since 5.2.0. We've had issues with 5.2 something. We've moved back to 4.2.0. We stayed there for quite a while, and now we are Flyway 5.2.4. Again, the example shows that it is possible to follow official release notes, and then you might discover incompatibilities. And it also might turn out that some versions that don't explicitly say claim to support JDK 11 might just happen to work. Your experience, of course, will vary. I have to mention JEP 3.2.0, which means the JEP in which they took JAXB away from within the JDK. So that means that just some pieces of code were taken out, and you have to now take them in as dependencies, which means you'd get to rule on the versions, and then you don't get clashes with what comes with the JDK. Especially if you use CodeGen for web services, as they used to be called, you will have to add a library for that. Languages. What languages do we use? Well, we use multiple languages at Revolut. Our primary language is Java, but we also have Groovy. Yes, why? Because Spock. We've upgraded Groovy to 4.16. I won't spend too much time on it because this mostly just worked. But I have to mention that Groovy is basically what's holding us back from moving to further versions of the JDK. If you look at Gradle's build history, Groovy again was the thing that held Gradle for a bit from going to support JDK 14. So if you don't have a lot of Groovy in your code base and you want to use modern JDKs, well, sometimes Groovy is a source of incompatibilities. It's not that it's the only source, but from our experience, we would like to have had less Groovy than we have from the point of view of JDK upgrades. Kotlin supports JDK 9 up to 12 since 1.3.30. This just worked. Scala, we just switched versions. That's it. There is a small note about Scala, and same about Kotlin, actually. They don't really fully do modules, but we don't use modules. It's a choice. We don't do publicly available libraries. We're building services, which means our services, as you already know, are isolated within containers. So we don't benefit from the JDK module system yet, which means we didn't really pay attention and we didn't really worry about Scala and SBT not supporting modules. Now, testing and Postgres. I mentioned Postgres. There was another quirk here. We used to run this guy, PostgreSQL embedded. It just wasn't working with JDK 11, and yeah, we then somebody even committed a JDK 9 plus compatibility, and then somebody even committed a change called not actively maintained anymore node, which is a self-explanatory. What we did is we went to the recommended solution, the one that I would recommend to you as well. We started using test containers and we're happy. So if you're doing something strange with Docker and you can replace it with test containers, try replacing it with test containers. And dependencies, because obviously we don't have one application, we have multiple. If you have a model in which application A depends on B, depends on C, first start with the outside of the onion. That's probably obvious, but somebody could say, well, start with the inside, and then you will be forcing yourself to go Java 11. We started by making the applications compile with 11. That required small changes, discovering what libraries, what illegal names there were. After getting that, we started to test using 11, so run unit tests on 11. And then we started to run the outside application using JDK 11. We do have a lot of unit tests and a lot of integration tests, as in the number of unit tests alone for a single big app is counted in tens of thousands. So those test cases, they do cover the application in quite extensive detail. But that also means that we have some safety. If the test suite has successfully completed, we would be good to go. We discovered some problems with when upgrading, and I'll tell you about them in a second. But basically, after you get through the outer layer, you go one layer in, full inception basically, and then you should be good to go. Things that I should mention. Bouncy Castle in JDK8 or before, it was common to install Bouncy Castle jar into JRE libx. If you don't know Bouncy Castle, think something encryption, something security. If you do know Bouncy Castle, you do know what I'm talking about. This does not exist anymore in JDK 9. So, and later you do the approach to declaring other providers for security has changed. There is a link at the bottom. If you want slides, message me after the talk. VM options obviously changed. Obviously, unified GC logging, so you declare your GC logging output differently. How it's changed? Well, this is an example. I don't expect you to remember this. What's more important or more useful to be remembered is jacoline.dev, which is something that can verify your JVM or JDK runtime flags. And if you want to switch flags, you can just switch the JDK versions, and it will tell you what's deprecated, what's not really okay anymore. This project is alive, so it's just a useful tool. Also, if you want to learn about XX changes or what different XX options are available in different JDKs, there is this awesome website by Chris Who Codes, which should have a link somewhere, that lists all the flags for many JDKs, and you can read about them and you can search, and it's awesome. If you feel like exploring, it's a great thing to do in the break, or maybe if there is a boring lecture, but not today, that's for sure. JDK 9 has a new zip file implementation, so you don't need to mmap. If you've used this flag, basically you don't need it anymore. If you don't know what I'm talking about, you probably didn't run into it. That's about how zip files were being supported by the JDK. If you were doing a lot of zip files for for performance reasons, you might have mmapped them before. Time precision. That's an important one. There was a feature released for JDK 9, which increased the precision of the Java time clock system UTC. And that, if you look at the Joda Stevens blog, it's the precision has been increased, and it gets it used to take in milliseconds. Now it's taking in sometimes microseconds, and it really depends on the operating system. That's where the change is actually mentioned. It's there if you look for it. But side note, awesome article by Shipylef about the problems connected with time on computers. But basically, in practice, what this means to us developers is if you're running JDK 8 as above, and you ask, you do an instant now or something like that, you'll get 3 digits of precision, if the operating system supports it, of course. In JDK 11, you will get 6 digits of precision at the very, very end. What does this mean? That means that, for example, Postgres stores timestamps with microsecond precision, so it cares about all digits and all 6 digits after the decimal point. If your tests were used to having only 3 and compare only 3, and now there is 6, and your tests might explode. Or you might have unexpected results if you're running it in somewhat strange way. Basically, the precision of time that you have to now have to deal with has changed. What is my recommendation for this? What did we do? Well, instead of using instant now, we started injecting our own time provider and replaced the base JDK entry paths, and we have our own. Our time provider has configurable precision. So for tests, it can do what we want it to do, and it will always do what we want it to do. It will not default to the operating. Cannot be more precise than the operating system, but everywhere will use the same. Useful to know, if you get into that. Data informators, they had bugs, surprisingly or not surprisingly. So you might find null pointer exceptions when parsing time zones. It's a known thing. You have to use a different locale sometimes, or you have to do workarounds. You might get into, yes? Awesome, questions, perfect. Let's take a break then. Shoot with the first one. Strzelaj pierwszym.
I will read that. Kudos for this presentation. Looks great. Some projects have older code bases though, with many violations preventing them for easy JDK 8 upgrade. They will stick around on JDK 8 until its end of life. Do you have any advice how to convince leadership to this investment?
This is a very good question, but let's talk about it towards the end, because it requires a more thorough answer. It's a very good one. I want to talk about it, but let's do it after.
There's also one more question. What was the JDK you use? Open JDK?
Adopt. I did say we adopted the JDK, so that's adopt Open JDK.
That's the all for now, at least.
Dziękuję. Thank you, Kuba. So we run into compiler bugs. It's not to say you will run into the same, but it's to show you that you might get compiler bugs when upgrading JDKs. It's not as scary as it looks, but they are there, and I cannot say there are no problems whatsoever. The problems are there. When you look at the JDK bug repository, you'll see duplicates of duplicates of duplicates. Some of them are related to type inference and generics, specifically something like this. What you can do is slightly adjust your code so that it just does not cause this bug to happen. Obviously, with subsequent releases to JDK 11, so the 0.6 release, for example, some of those bugs are being eliminated, but sometimes they are being fixed in 12 or 13 or 14. And in such cases, if they have not been backported because they were not considered important enough, the two options if you want to get rid of them is either not write code that triggers that bug, or upgrade to a further JDK version. We chose to stay on 11. We did not upgrade to anything further, so we have just changed how we write code a bit. That's a bug that bit us actually enforced some changes. What it looks like is if you have generics with question mark extends profile, for example. So if you have some interesting captures in your code, well, this might stop working. This is slightly suboptimal because Java's type system is already limited as it is, which means you have to make it compile and to not make it explode, because this explodes in runtime, what's not really visible here. You can, for example, use Scala to capture the types and use Scala to be your type police. Or you can, while in Java, write a bit more tests. For us, that was a bit unfortunate because we don't have Scala in all the projects. From my previous work experience, using Scala as a backup tool for Java type system is a good option sometimes. But if in your workplace, or if you just personally don't want to use Scala, well, you're stuck with Java, and then this might happen, and this might force your generics to be slightly less precise sometimes. That's unfortunate, but well, that's what it is now. When I was taking this picture, which was I think 2 months ago, this was still in progress. So when they get to fix it, you'll see which JDK is finally safe to use. It's good because those issues come out and they get fixed and they get released. But the problem with staying on a version is you have to rely on backports. And then I have to mention runtime reality of running with JDK 11. JDK 11 switches to G1 by default. So if you don't specify any flags, you run G1, but it's a very different G1 than the one in 8. You could call it you could call it something else even. The algorithm is different. It also is multi-threaded in the full GC phase. It also behaves much better than it used to in JDK8. And if you're really forward thinking, the G1 in JDK13 is even better. But that's a side note. What this means from our specific context is we have G1 that keeps running, and we don't have to pay attention. We don't have to tweak the GC in almost any way. I always say, and I do keep saying that you should capture GC logs, but at least in our current situation, we don't have to investigate them too heavily, because no magic is required to run human perception posters. I say human perception posters because Revolut, the first entry point to the app, to the service for most people is a phone app. Phone app talks to services on the backend. Services are in Java. Those services have some performance budgets to spend so that the human thinks that the service runs quickly. Obviously, there might be slowness caused by anything else on the way. But our experience specifically is as usage grew, we kept increasing heap sizes and we kept observing no issues. We're in the tens of gigabytes range even here, and we've had no issues. If you were running other JDKs and you cared, going from, let's say, 4 gigs of heap to, let's say, 32 gigs of heap would be, I know some people would just open their eyes quite wide and say, yeah, are you sure? Just like that? For us, it was okay. As I say, less problems with GC logs. One thing that we encountered that was an actual issue was out-of-memory failures. It has been our experience that JDK 11 requires a bit more reserved memory than JDK 8. If you've seen this bug, we don't see that too often with JDK 11. We get this usually fails faster. And it's it is useful because if you're running containers, you can just restart the container, whereas JDK 8 would hang on for up to 98% of time until the JVM decided, no, I'm spending too much time in GC, and the application code isn't running. So if your application was freezing for minutes because it was running GC, and then only to fail without anything useful, our experience with G1 was that the G1 will just give up much quicker if it cannot allocate. Also, after moving to JDK 11, some containers started dying. Why? Because reserved memory appetite has grown slightly by small amounts within single percentage digits. But that was enough to cause failures because with containers, you can exactly calculate how many megabytes you need everywhere. Changes? Well, we could imagine we're doing a demo because we will not, because we will run out of time. Let's imagine we go to Oracle Cloud now. You can see the login screen here. You can see me deploying, and basically the top picture is JDK 11 running on Oracle Linux with a 10 gig heap space. Slightly bigger reserved memory immediately. JDK 8 below, slightly less reserved memory. Somebody could say, yeah, those numbers make no sense. You're running a 10 gig heap, and the top is closer to 10 gig, but it's not really exceeding that. Yes, that's correct. Bottom line, RSS of Java 11 would be bigger. It would get allocated faster. So for a very fixed container size, we need to decrease XMX and XMS. But also we would get out of memories faster. Not faster as in they were unexpected, but if there was an out of memory error that would happen eventually, JDK 11 would deliver this error faster, which means we can restart the container or be notified about the problem faster. So that's good. I'm speeding up because we will be running towards the end. I think I have my last 4 minutes. Language features adoption. We I measured how many vars people started to use in a specific project over the period of 53 weeks and 6 days. That data is not publicly available, but it's source code of one specific service. This is the adoption of vars. People like it. People were cautious at first, but this quickly caught on. Now we have it in our guidelines that's you should use vars if it makes sense, and new code will start using vars. You will see a dip here. So there is a dip. Why? Because we have spun off a service outside of the big monolith. And then as of release 9, underscore is a keyword. What can you do? Well, it's very easy. Compiler will complain. It will tell you that you cannot really do it, but you can do this. And if you can't see what happened here, this is a double underscore. A double underscore is a perfectly legal anything. Another thing, Java, flight recorder, mission control, they are free and open source. They don't require a license to be run in production. This is in comparison, in stark contrast to old flight recorder and old mission control, which were requiring an Oracle license to be run in production. It was safe to run it in dev and in test. Now it's just open source and free, and you can use it, and it just works, and it's awesome. If you've never tried this tool, I would recommend you do. What is next for us? Well, I already mentioned Java 13 has a lot of improvements in G1 space, but it has no support anymore. Probably not going to go there. Java 14 has amazing features for observability, like Java Flight Recorder event streaming, but Gradle, when I was making most of those slides, did not support Java 14 yet. Now it does. So probably we're going to give it a try. We are going to experiment with GraalVM, but I cannot say we want to migrate. That would be way too early. GraalVM is awesome, exciting, but there is a lot of questions around that. And then how should you go about it? Well, aside from the very good how to convince your mighty overlords to switch to Java 11, if you want to make your project compile, start with compiling with 11. Obvious. Update your plugins, update your library dependencies to something reasonably recent. Try running the test and see how it works. It's not a very painful process. It's quite doable. The bigger problem is the human change. So bottom line is I want you to upgrade to Java. As I promised, picture, so I have to drink. If you have questions, now is the good time. If you want slides, email me. AGS at Revolut. Easy. Kuba, do we have more questions?